Moving on to 8.6, buffer solutions and their applications, which is a major concept. Multiple industrial processes rely on buffers, including pharmaceutical, food, and to textiles. A buffer solution is a solution that pH of which does not change significantly when a small amount of acid or base is added to it. Such a solution has a constant pH which does not change on keeping long time. An aqueous solution of a weak acid or a weak base contains two substances which react with each other to a limited extent. These substances are acid, water, or base and water. When a third substance is added to the solution, an effect can be produced on the original pair of the reactants in solution, acid and water or base and water. The third substance may suppress the reaction of the original two reactants, and for example, if sodium acetate is added to an aqueous solution of the acetic acid, it does not react directly with acetic acid or with water. However, the increase of the acetate ions suppresses the ionization of acetic acid, and the equation below illustrates the equilibrium of the aqueous acetic acid solution. On addition of sodium acetate, the solution receives sodium ions and the acetate ions as a result of the ionization of sodium acetate. The presence of sodium ion does not affect the equilibrium since it is not involved in this reaction. However, the increase in the concentration of acetate ion appearing on the right of the equilibrium reaction will shift the equilibrium to the left. Now consider a solution containing both a weak acid and its conjugate base as a soluble salt. Such a solution is called a buffer solution. One buffer solution can be made by dissolving sodium acetate and acetic acid in water. It may be recalled that acetic acid is a weak acid and conjugate base are present. The acidity of this solution is less than a solution of the acetic acid, and because the acetate ions hinder the ionization of acetic acid. In addition, the buffer solution has a special character of resisting change in its pH, even when a small amount of strong acid or strong base is added to it. And such a solution has the ability to neutralize either acid or a base. And if base is added to the buffer solution, the hydroxide ions will be neutralized by the acetic acid in the buffer. On the other hand, if an acid, say HCl, is added, the proton's H positive ion produced will be consumed by the acetate ions present in the buffer. So the buffer solution may contain a weak acid and its salt from a strong base, or a weak base and its salt from a strong acid. By choosing the appropriate components, a solution can be buffered at any pH. The following examples explain the calculation associated with buffer solutions. The concentration of conjugate base in the reaction mixture is predominantly supplied by the salt, which is strong electrolyte, and therefore assuming the concentration of conjugate base equal to that of the salt and original concentration of acid as an equilibrium concentration, pH of a buffer can be calculated.